Right now we're going to do an introductory video that's going to be important building blocks for the unit circle in trig. Before you can understand the unit circle in trig, it's really important to understand how to solve for unknown parts of special right triangles. The special right triangles are going to be the 30-60-90 triangle and the 45-45-90 triangle. Let's start with the 45-45-90 triangle. It's derived by splitting a square in half. So let's take a look at that. Okay, so we know all sides are congruent. And you also know from geometry that since this is congruent to itself, these two triangles, side, 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 congruent to side, side, side. That is one way to do it. Or side, angle, side, congruent to side, angle, side. Either way, these triangles are congruent, meaning the corresponding parts are also congruent. So this corresponds to this. These must be the same measure. And since we know every angle is 90 degrees, this angle has been split evenly. These two angles are congruent, so it must be 45 apiece. So we have two congruent 45-45-90 triangles. So let's just focus on one of them. I'll just pull out the bottom one, this one here. So let's say we want to know what is the length of the hypotenuse in terms of x. So x, x, and then how do we solve for the hypotenuse, which we'll call c. And for now, we'll call this a, and we'll call this b. So Pythagorean theorem says that a squared plus b squared equals c squared. We're going to solve for c. X squared plus x squared equals c squared. 2x squared equals c squared. So then square rooting both sides, I'll turn it around with the variable on the left. The square root of c squared, normally I'd say positive or negative root 2x squared, but we're not going to take into account negative square root because we only want positive solution because this is distance. So the square root of 2x squared will be root 2 times root x squared, which would be root 2 times x, or simply x root 2. So this will now be x root 2. That's important. We're going to use this in the unit circle. So x, x, x root 2. So the summary here, we've just proven that anytime you want to go from leg to hypotenuse, you can multiply by root 2. And to go from hypotenuse to come back to leg, you just divide by root 2. So let's see how we can apply that. Simple example is if I told you you had a side that is, say, 7. If I tell you x is 7, knowing this is a 45-45-90 triangle, then this must also be 7, and then x root 2 must be, the hypotenuse is now 7 root 2. Okay, so x, x, x root 2, 7, 7, 7 root 2. But who says this has to be an integer here? What if we had an integer here instead? That's no problem, because we said to go from leg to hypotenuse, you'd multiply by root 2. So to go from hypotenuse back to leg, either one, you would divide by root 2. So if you have a whole number here, not a problem. So let's take a look. Let's say I told you this side is 4. Now, knowing that it's a 45-45-90 triangle, how do we go backwards and find out what is the length of each leg? Now, you could use Pythagorean theorem, but it's much quicker to use this pattern. This is going to be helpful in the SAT. It's going to be helpful for unit circle. So let's just divide by root 2 to come back. So the leg is going to be 4 divided by root 2. So x will be 4 over root 2. And rationalize the denominator, multiply by root 2 top and bottom. So have now on the bottom, we have root 2 has been squared. Square root and square cancel out, leaving the radicand 2. And on top, we'll just have 4 root 2. So this becomes 4 root 2 over 2, or just 2 root 2. So each side is now 2 root 2. Now, an important triangle that's going to be used in the unit circle is, instead of this hypotenuse being 4, what if this hypotenuse is 1? Let's try that. So again, if we have 45, 45, 90 triangle, let's say this is 1. So to go from hypotenuse back to either leg, divide by root 2. So x equals 1 divided by root 2. And as before, we can rationalize the denominator. So just multiply the top and bottom by root 2. We will get root 2 over root 2 squared, or just root 2 over 2. That's going to be one of the most important numbers we're going to learn in the unit circle in another lesson. Root 2 over 2. So each leg here would be root 2 over 2. Okay, let's talk about the 30, 60, 90 triangle. So instead of splitting square, we'll now split an equilateral triangle in half. So let's take a look. The equilateral triangle is also equiangular because we know congruent sides are opposite congruent angles. So let's say we're to split the triangle like this, and we end up with 2 congruent triangles. You could use a geometric proof on that, use your knowledge from geometry to prove that this triangle is congruent to this one. So we said equilateral is also equiangular, and knowing these triangles are congruent, this angle and this angle must be the same, and we know equiangular means the original triangle is 60, 60, and this whole angle is 60. Split into 2 equal parts, these must be congruent angles here, 30. And since we split this in half, we'll call this x, and this is now 2x. But we said it's originally an equilateral triangle to begin with, so these sides must also be 2x. So as with the square, splitting into 45, 45, 90 triangles, we had none inside. Last time we were solving for the hypotenuse, and now we're going to solve for this height, which I'm going to call that height b. So if we were to take this triangle here and solve it, call either leg A and B, as long as the hypotenuse is C, no problem. C is 2x, A is x, and B, we don't know yet. Let's find out. So A squared plus B squared is C squared, leg squared plus leg squared is hypotenuse squared, x squared plus B squared equals, make sure you put parentheses here, because otherwise it means twice x squared, which is not what we meant. This is 2x times another 2x, which is going to be 4x squared. So a really common trap is to have x squared plus b squared equals 2x squared, not 4x squared. So it's going to make a big difference. If we want to get b by itself, we will subtract and combine like terms. So now we have b squared equals 3x squared. And square rooting both sides, we'll now have b equals root 3 times root x squared. And again, we're only going to take into account the positive root. So this is going to be x root 3. So this is an important pattern in the 30, 60, 90 triangle. Now we have x, 2x, x root 3. So let's take a look. So short leg is opposite 30 degrees. The long leg is going to be x root 3. We just solved for that. So here is x root 3, and then this is 2x. So short leg is x root 3 for the long leg, and then 2x. So let's see how we can apply this pattern. So let's say I gave you 30, 60, 90 triangle. And let's say the hypotenuse is 10. Okay. So using the pattern for 30, 60, 90 triangle, let's just look at these side by side, it might be helpful. So 2x, x root 3. X is across from 30, x root 3 is bigger, across from the bigger acute angle, 60. So in this case, we see 2x equals 10, and we want to know what is this side and what is this side. So to go from hypotenuse to short leg, divide by 2. So we'll start with that. Divide by 2, and we'll now have 5. And to go from the short leg to the long leg, multiply by root 3. So this multiply by root 3, and now we have 5 root 3. 5 root 3. Okay, so how do we apply this to the unit circle case in another lesson? So instead of the hypotenuse being 10, it's going to be important to have the hypotenuse equal to 1. So let's take a look. If the hypotenuse is 1, now how big is this? And how big is this? So we follow the same pattern, knowing that this is a 30, 60, 90 triangle. To go from hypotenuse to short leg, simply divide by 2. So 1 divided by 2 is just a half. And then to go from short leg to long leg, multiply by root 3. And half of root 3 will give us root 3 over 2. A little more detail on that. If you wanted to say 1/2 times root 3, you could say root 3 over 1. So then you get root 3 over 2. Okay. So these are going to be very important numbers in the unit circle. We've seen root 2 over 2 for each leg. Let's just do a quick summary. The 45, 45, 90 triangle. If you have a hypotenuse of 1, then we'd say each leg is root 2 over 2. And in a 30, 60, 90 triangle, let's say we turn it this way. The hypotenuse is 1, the short leg opposite 30, 1/2, and the long leg is root 3 over 2. So all of the unit circle is going to boil down to just these 3 numbers. The only thing that's going to change is positive or negative based on quadrants. You only have to know 3 numbers to be a master of the unit circle, and we'll talk about that in another lesson shortly.